Today we're going to focus on target 10C, model linear and exponential function. So number one, Mike is saving for some new medical gloves which cost $55 for a case. He already saved $17. His goal is to have enough money saved in 6 weeks to pay for the gloves. Write an equation that represents how much money he needs to save each week to meet his goal. This situation is represented by a linear equation. So the way you're going to set it up, the cost of the glove, which is 55, equal to the number of weeks that they have to save, which is 6 weeks, times X, plus the amount of money that they already have saved, which is 17. So again, the 55 represents the cost of the gloves. The 6 represents the number of weeks to save. And then last but not least, the 17 represents how much you already saved. Again, the question was just asking us to write the equation, so that is my final answer. 55 equals 6x plus 17. Number 2, a species of monkey initially had a population of 12,125. When scientists first began studying it, since then the population has increased 1.2% each year. If this trend continues, how many of the monkeys in the species will there be after 11 years? So because of it's a percentage, that gives us the clue that this is an exponential function. So since it's exponential, we're going to use the formula y equals a sub 1, parentheses, 1 plus or minus r to the x power. So now we're going to go back to the problem and figure out what we're going to substitute in. So it's going to be y equals a sub 1 was where the population started. The population started at 12,125. Parentheses, 1. The clue word here is increase. Because it's increase, I'm going to add r. R in this case is 1.2. Remember, you got to move it twice to the left because it's a percentage. It's going to be 1, 2. So that's where my new decimal is. I'm going to put in a placeholder and it's going to become 0.012. And we're going to raise that to the x power. However, in this problem, we're going to raise it up to 11 because they're asking us to solve for 11 years. So I'm going to simplify the 12,125 parentheses 1.012 to the x power. Again, to the 11th power. So that's exactly what I'm going to type into my calculator. So add a calculator. 12,125 parentheses 1.012. I'm going to raise that to the 11th power, which equals 13,825.1. So y equals the 13,825.1. The only problem with this is it's talking about monkeys. You cannot have a 0.1 of a monkey. So I'm going to round it up to the whole number. So it's going to be y equals 13,826. I'm going to round it to the nearest monkey. All right, we're gonna keep going forward. Number 3, the image models the number of cues for figure 1, 2, and 3. Actually, A and B. Will a graph of the function represented by the image be exponential or linear? So here you're gonna have to kind of figure out the pattern visually through the graphic. So here I started off with 1 square. Here, the next one, I moved on to 2 squares. But for the third term in the sequence, I have 4 squares. So now you got to figure out, how did I go from 1 to 2 to 4? Did I add, subtract, multiply, or divide? In this case, I multiplied by 2. Since I'm multiplying, it's exponential. Remember, in order for it to be exponential, you have to be dividing or multiplying. Next up, part B. We're going to be basing it off of the number of stems off the leaf. So in this case, I have 2. Next one I have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So now the question here is, how did I go from 2 to 4, 4 to 6? Did I add, subtract, multiply, or divide? I ended up adding 2 each time. Since I'm adding 2, it's linear. Remember, for it to be linear, you're either going to be adding or subtracting. Number 4. A species of a bat on an island initially had a population of 625 when scientists first began studying it. Since then, the population has increased 4.5% each year. If this trend continues, how many of the frogs in the species will there be? Frogs? Hold up. This should be bat. In the species will there be after 10 years? So we're going to repeat the same process like the other one. Because it's 4.5%, that's my clue to know that this is an exponential function. So it's going to be y equals a sub 1 parentheses 1 plus or minus r to the x power. Again, the problem itself gives me all the information I need in order for me to solve for this problem. So it's going to be y equals a sub 1 is where the population started. It started at 625. Parentheses 1. Clue word here, it increased. Because it's increasing, it's going to be 1 plus r. R is 4.5%. Remember, you have to convert that to a decimal. 4.5%. Move the decimal to the left 2 spaces and becomes 0.045 to the what power? In this case, they want us to solve for 10 years. So it's going to be raised to the 10th power. Again, I do extra steps. I'm going to simplify before I put it in the calculator. 625 parentheses 1.045 to the 10th power. So that's exactly what I'm going to type into my calculator. 625 times parentheses 1.045, raise it to the 10th power. So I got 970.606. 970.606. Again, we're talking about bats. So we do not have a 0.606 of a bat. So I'm actually going to round it to the nearest whole bat, which would be 971. So in this case, in 10 years, there's going to be 971 bats. Number 5 is the same type of problem. The ant farm in Brenda's backyard initially had a population of 853 when she first began noticing them. Since then, the population increased 5.6% each week. If the trend continues, how many ants will there be after 12 weeks? Again, your clue word here is the 5.6%. This leads me to believe this is an exponential, so it's going to be y equals a sub 1 parentheses 1 plus or minus r to the x power. Again, the problem gives me the information I need in order to solve this problem. Y equals a sub 1, which is where the population began, 853, parentheses 1. Since it increased, I'm going to add 5.6% is written as 0.056. And I'm going to raise it to 12 because they want us to figure out after 12 weeks. Again, I usually simplify 853 parentheses 1.056, raise that to the 12th power. So that's exactly what I'm going to type into my calculator. 853 times parentheses 1.056, raise that to the 12th power. And that's going to be my answers. 1,640.27, 1,640.27. Again, we're talking about ants. We do not have 0.27 on my ant. So I'm going to raise it up to the next whole number, which is 1,641 ants.